Hey students, this is lesson 6.5. In this lesson, we're going to learn how to graph linear inequalities in two variables and to use linear inequalities when modeling real-world situations. Go ahead and do the review here, and I'll check back with you. All right, first thing we have to realize is how to identify solutions of a linear inequality. Now, since there's two variables, you could think of this as coordinates on a coordinate grid. And so the two, if we substitute both values in for x and y, it has to be true. So let's check this first one. So in this one, x is -5, y is 2. If we put that in this equation, we get 2 is less than -5 plus 2. And if I simplify that, I get 2 is less than -3, and that's a false statement. So, is this an ordered pair solution? The answer is no. Okay, and for B, again, we're going to substitute 6 for y and 4 for x, and just see if it's true. And this time we get 6 is less than 6, and again, that's false. So we're going to say no, this is not a solution either. So neither of these are solutions. So just substitute the values in and check and see if the resulting inequality is true or false. Let's go ahead and try that. All right, now to graph. So what a graph it represents is every possible solution to this inequality. So in this one, some examples would be some obvious examples. Let's say y is 10. 10 is definitely less than 15 minus 1. So the point 15, 10 would be a solution to this. Another point, how about this one? 0 is less than 3 minus 1. That's true, right? So the point 30 is a solution. So on this graph, there's a point at 30 that is a solution to this. Now, what we want to do is show every possible point that's a solution. Now, to do that, we're going to actually have to cover an area of this graph. And I'll show you how to find that area. Okay? There's going to be a process that you do. The first thing you're going to do is find the equation. So find, and we call that the boundary line. And then if it's a less than or greater than, then we're going to use a dotted line. If it's a less than or equal to or greater than or equal to, we're going to use a solid line. So go ahead and jot these down. So the first thing you want to do is find the equation, the line of the equation. We call it the boundary line. If it is a less than or greater than problem, we're going to use a dotted line to show that values on the line are not solutions, and we're going to use a solid line if it's less than or equal to or greater than or equal to show that values on the line are solutions. Then we're going to test points not on the line to see if it is a solution, and then shade the side of the line with the solutions. So let's go ahead and do that. We're going to graph y equals x minus 1. To do that, we know the y-intercept is -1, so we'll put a dot there. Since we have a less than here, we're going to use a dotted line. And then we just need to know the slope. And the slope here is 1, or 1 over 1. We're going to use the rise and run. So we can just go 1 over 1 here. And then we're going to use a dotted line to graph that. And so that'll look like that. All right. Now we're going to test points that aren't on the line to see if they're solutions. And the easiest point to test is 0, 0. So we're going to substitute 0 for y and 0 for x, and just check to see if it's true. So we get 0 is less than -1. Is that true or is that false? That is false, which means that the point 0, 0 is not a solution, and that tells me that points over here on this side of the line are solutions. Now you could check one if you wanted to, like how about this one, 4, 1. So is 1 less than 4 minus 1? 1 is less than 3, right? So that's true. And we can be certain that every point on this side of the line is also going to be true. So we're going to shade over there. Maybe I'll use a highlighter to shade. And maybe I like this color. So every point on this side of the line, and remember that this is continuous. Sorry, I went over the line. Guess I didn't pass my kindergarten coloring. But anyway, so that whole shaded area represents all the solutions. Go ahead, you try that. All right, what is the graph of each inequality in this coordinate plane? Now on here, we want to graph x is less than 2. So again, we're going to find the boundary point, the boundary line, which is x is equal to 2. And if you remember, that's the line with all the coordinates that are that have an x coordinate 2, and that's a vertical line at x equals 2. And so I'm going to put a dotted line there at x equals 2. All right, and then I'm going to shade the side of that line where the points are true. And again, I can test like the point 0, 0. And of course, I just have a 0 value for x. I want to make sure 0 is less than 2. That's true, so the point 0, 0 should be shaded. So I'm going to shade that side of the 2. And that looks like that. And then y is greater than or equal to 3. My boundary line is y equals 3. And y equals 3 is a line where every y coordinate is 3. And since it's greater than or equal to, I'm going to use a solid line for this one. At y equals 3. Put that there. And then I need to shade where values of y are greater than or equal to 3. That'd be like where y is equal to 4 or 5. And of course 0 would not be shaded because 0 is not greater than 3. So I'm going to shade above the line. And that looks like that. So anything in that green zone, y is greater than or equal to 3. All right, go ahead, you try that. All right, the last thing we're going to do is learn how to graph. Second to last thing we're going to do here is learn how to graph a real situation. So suppose you can spend no more than $20 for hot dogs and hamburgers for a picnic. Hot dogs cost $5 per package, hamburgers cost $8 per package. What are 3 possible combinations? Let's graph this so we can see where the possible combinations are. To do that, let's let x equal the number of hot dog packages we buy, and let y equal the number of hamburger packages we buy. Then the inequality that would represent this is 5x, because it's $5 per hot dog, package of hot dogs, plus 8 times y. So this is how much money we're spending, has to be less than or equal to 20. Now, if I want to graph this, I think the easiest way to graph it would be to just find the intercepts and the x-intercept of the boundary line. So the x-intercept of the boundary line would be if we put 0 in for y. And so this part right here would just be 8 times 0, which is 0. So I would just do 20 divided by 5, which is 4. And the y-intercept is 20 divided by 8, which is 2.5. And now I'm just going to graph those and use that to make a graph. What the intercepts really mean is if you don't buy any hamburgers, how many hot dogs could you buy? If you don't buy any hot dogs, how many hamburgers could you buy? So I'm going to go ahead and graph this now. All right, so here's my graph. Now my x-intercept is 4, and that is the number of hot dogs I buy down here. And my y-intercept is 2.5, and that's the number of hamburger packages I buy. And we know that we have to buy a positive number of packages, so I don't need negative parts of the graph. I only need the first quadrant. So I'm just going to draw a line from here to here, and I'm making it a solid line because it's less than or equal to. And then I can just shade now. All my possibilities are in this area. So an example of a possible number of hamburger buns, we could buy 1 hot dog 1 hamburger, 2 hot dogs, 0 hamburgers packages, 2 hot dogs, 1 hamburger, and so on. Those are 3 possibilities. Go ahead, you try that. Notice on the graph here that I just put dots on there, and that's because this is I was just looking for whole number combinations. You could actually do any, and we could just shade all of this in here. So you could do half pounds. All right, the last problem here, writing inequality from a graph. Okay, what we're going to do is look at a couple of things here, like what is the equation of the boundary line? Is the line a solid or dotted line, and which side did we shade? One thing you may have noticed is that if it's written in slope-intercept form, if you're shading below the line, it's been less than. If you shade above the line, it's been greater than. So the hints on this one is, well, our y-intercept is 0, 3. So just from that, and our slope is, let's find the slope here. So the slope looks like our rise is 1 and our run is 2. So our slope is 1/2. So we need 1/2 x plus 3. And we're shading below the line. So that means we're going to have a situation where we're less than. So let's eliminate the ones that aren't less than. That would be this one and this one. Those are both greater than. And then the other thing we want to look at is it a solid line or a dotted line? In this case, it's a solid. And remember, a solid line means greater than or equal to or less than or equal to. So we can eliminate choice C, and we're left with D. Our equation is y is less than or equal to 1/2 x plus 3. Go ahead and try that. All right, that's it for this lesson. Go ahead and do the lesson check, and we'll talk about it next time we meet.